We can observe here. For example, copper glands converted into copper oxide and form sulfur dioxide. In this copper oxide again combines with copper sulfide to form copper and as well as sulfur dioxide. This is the extraction of copper metal from their ore. In the same manner, lead also. Okay, you can observe here. Galena converted into PbO. This PbO again combines with PbS to form 3Pb plus SO2. It is also one of the reaction. Another one is self-reduction. Mercuric sulfide, cinnabar, converted into mercuric oxide. In this mercuric oxide, on heating to form mercury and oxygen gas. These are all self-reduction or auto-reduction. Sulfide ores are less electropositive metals like mercury, zinc, lead, copper. Not zinc here, sorry, lead. Pb. And another one is displacement reaction. Actually here, aluminum thermite reduction here. It involves reduction of aluminum oxide, chromium oxide, manganese trioxide with the help of thermite reaction. Okay, what is thermite reaction, sir? Reaction in which iron oxide react with aluminum in 3:1 ratio to form molten iron and Al2O3 and huge amount of heat energy liberated. Then the reaction is called thermite reaction. The reaction between iron oxide with aluminum to form a molten iron. In this molten iron is used to the joining of railing of railway tracks and also cracked joining of cracked machine parts is called thermite reaction. Aluminothermite reaction. For example, if you take here one more example, aluminothermite reaction. Aluminothermite reaction. That means here chromium oxide combines with aluminum to form Al2O3 plus 2 chromium and heat energy is liberated. Like that, Mn2O3 is react with aluminum to form Mn3O4 to form Al2O3 plus 3 Mn plus heat. Okay, these are the examples for thermite reactions. Okay, the reaction between iron oxide with aluminium, that is 1:3 ratio. The metal oxide is profitably displaced by another metal, releasing of huge amount of heat energy, is called thermite reaction. These are the various methods to extract the moderately reactive metals like iron, chromium, manganese. Thank you. Now, how to extract the low reactive metals? Okay, that is called simply hydrometallurgy. How to extract the low reactive metals? For example, either silver, gold, or mercury. Okay, now how to extract the silver, sir? It is based on the fact that more electropositive metal displaces less reactive positive metal from their salt. More reactive metal which displaces to less reactive metal from their compound is called okay, how to extract the silver, sir, here? This process is also called wet process. It involves extraction of metals involving aqueous solutions. For example, silver, gold, zinc displaces from sodium argentocyanide. Silver is reacted with sodium cyanide in the presence of air and water to form 4 Ag 8 NaCl to form sodium argentocyanate cyanide. This name is the sodium argentocyanide. In a sodium argentocyanide, that means here, if you take one more example, AgCl combines with the sodium cyanide to form sodium AgCl taken twice, that is called sodium argentocyanide, and as well as the NaCl. In this is sodium argentocyanide is reacted with the zinc metal to form sodium zincate cyanate. That means here Na2Zn Cn taken 6 times and 2 Ag. This is the extraction of silver metal. In case if you take gold, how to extract the gold? Okay, one more process is there. Silver react with cyanides and also H2O and oxygen to form here 4Ag, same reaction, 4Ag 8Cn minus 2H2O gives rise to AgCN taken twice minus 2 plus 4OH minus ions. This one is react with zinc metal to form this AgCN taken twice, react with zinc metal to form Zn taken twice plus 2Ag. This is extraction of silver metal. Here, but here taken 4 times. The same manner, if you take here, instead of silver, now I am taking gold. That is 4Au combines with 8 cyanide ions, 2H2O plus O2 gives rise to AuCN taken twice for -2 plus 4OH minus ions. This AuCN taken twice react with zinc metal to form Cn taken 4 times plus 2 Au. This is information about how to extract the gold. These two are solids. Extraction of metals from their ore, especially low reactive metals. In case if you take mercury is available in the cinnabar form. Already self reduction, auto reduction is completed. Cinnabar, this is roasting process on heating. Mercuric sulfide converted into mercuric oxide. This mercuric oxide on heating to produce mercury as well as oxygen. Okay, these are the how to extract the low reactive metals. And finally, how to extract the highly reactive metals. Highly reactive metals by electrolysis process. I hope it is clear. You can observe this one. Okay, this is a 2 graphite rods inside the sodium chloride solution. Okay, one of the electrode is act as a anode. It is connected to the positive terminal of the battery. Another electrode is connected to the negative terminal of the battery, is called cathode. Ionization, NaCl molecules split into Na plus and Cl minus ions. At the anode, oxidation takes place. Increasing oxidation number or loss of electrons. Sodium try to chlorine try to lose chloride ion try to lose 2 electron to form chlorine gas. At cathode, sodium cation try to gain 1 electron to form sodium metal. The sodium metal is deposited at cathode. This is information about how to extract the highly reactive metals by using of electrolysis method like this. Electrolytic refining, highly electropositive metals like this is information about how to extract. And finally, third one is refining or purification of the metals. Okay, what is the refining or purification of the metals, sir? Refining or purification of metal. There are various methods are there. Physical methods, chemical methods. Again here physical methods. There are various physical methods are there. First one is liquefaction. Second one distillation. Third one, zone refining. Fourth one is park distribution process. And chemical methods, cupellation, pooling, Van Arkel method, Mond process, and finally electrolytic refining. These are the methods. Okay, what is physical method? Liquefaction. This method is meant for refining or readily fusible metals like tin and lead and bismuth having less fusibilities. Okay, in this method is useful for the purification of tin and lead and bismuth having less fusible impurities. For example, zinc and lead mixture is separated by placing of crude zinc in the upper part of the sloping hearth, maintained at the temperature just above the melting point of zinc. Non-fusible masses lead remains behind the hearth. Zinc melts and flow down. Okay, it is useful for the purification of zinc, lead and as well as bismuth. Distillation process. What is distillation process, sir? Okay, volatile metals like zinc, mercury are refined by in this method. Zinc, mercury refined by or purified by in this method. Okay, crude metal is heated in a retard and as a result pure metal gets distilled and impurities are left on the retard stand. Zone refining. Okay, highly purified metal is obtained by this method. Okay, that is like germanium, silicon and gallium. These metals are purified by in this process. Okay, here in this process the metal and impurities have different in the solubilities. A circular heater fitted around the rod. Impure metal is slowly moved along the length of the rod. At the heated zone, the rod melts and as the heater moves on, the impurities pass into the molten zone form. The impurities are removed by the molten zone, while pure metal is crystallizes. To separate the pure metal by using of zone. Okay, that means here when a metallic rod is taken, on heating that rod, we can remove the impurities from there, germanium, silicon and gallium. And Fox distribution. In this process is useful for extraction of silver and gold from lead. Lead నుంచి మనం వీటిని separate చేయొచ్చు. That means here in this process, out of two phase systems of molten zinc and molten lead, silver and gold are more soluble in molten zinc. Zinc mercury alloys the former freezes out first. It is removed and zinc is distilled off. Okay, these are the four physical methods. And chemical methods, cupellation. Okay, in this method the impurity of a lead is removed from silver. Lead is removed from silver. Pooling also one of the purification method. Okay, in this impurity in metals can be removed in the form of metal oxides. It is used for metals having impurities of their oxides like Cu2O is removed from blister copper. Cu2O is removed from blister copper. Okay. And also SnO2 from tin. Van Arkel process. What is Van Arkel process, sir? Okay, in this method is mainly purification of titanium and zirconium metals. These two metals purified by the Van Herkel method using iodine. It is called vapor phase refining. Titanium react with iodine to form titanium iodide, and as well as on heating titanium and iodine gas. Simply it is purified by the titanium and zirconium metal. Mond process. Okay, Mond process is useful for the purification of nickel metal. Further heated, it is here 300 to 370 Kelvin or 350, here 450 to 470. On further heating to form nickel and 4CO. Okay, these are the refining of or purification of the metals. Yes, metallurgies are classified into various types. Okay, pyrometallurgy, it is also thermometallurgy, hydrometallurgy, and electrometallurgy. What is pyrometallurgy or thermometallurgy? The extraction of metal from their ore by using of heat energy is called thermometallurgy. It is also called pyrometallurgy. The extraction of metal from their ore by using of aqueous solutions is called hydrometallurgy. Hydrometallurgical process. Extraction of metal from their ore by using of electric current is called electrometallurgy. Thank you. Now we will continue. Next one is how to extract the metals. Okay, third one is self-reduction. It is also called auto-reduction. Self-reduction or auto-reduction. Actually here copper extracted from self-reduction, and also mercury also extracted from this method. You can observe here sulfide ores are less electropositive metals like mercury, copper, lead, and antimony undergo self-reduction. So what are the elements? Copper, zinc, lead, and antimony. Mercury also. These metals undergoes self